Thank you for the introduction. Good afternoon, everyone. First, I would like to thank all audience for sticking to the last session of last day. So today, I am going to share our recent work on FACE-AUDITOR, a useful tool for data auditing in facial recognition systems. My name is Zhikun Zhang, and this is a joint work between CISPA, Stanford, and University of Virginia. Facial recognition systems are widely used to identify a person through faces, and it has been applied to many applications. For example, we can use it in a company for access control. We can use it in an airport for border control. And we can also use it in a supermarket for facial payment. And we can also use it as a Face ID for the mobile devices. Recently, due to the scalability of metric learning-based models, they are widely used to implement facial recognition systems. The general idea is that the model users can customize a set of authorized users. And given a query user, model M can determine who is this person by comparing with the authorized users. In metric learning, we call the authorized users the support set, and it can be easily customized by the model users. And we call the query users the query set. And model M is trained such that the images from the same person can output higher similarities. However, the face data can be easily misused. So to prevent the face data from misuse, there are several existing solutions. The general idea of the existing solutions is to modify the raw face images before uploading them to the internet, such that the facial recognition system cannot learn useful information from these images. For example, the adversarial patch method will add stickers on face images to cause misclassification. An image cloaking method will transform the embedding of the face images to another person, such that the facial recognition system cannot learn useful information from these images. However, this line of work has some drawbacks. First, it can destroy the semantic information of the face images. Second, it can increase the difficulty of retroactivity. Third, they can be easily bypassed by more advanced attacks. So in this paper, we introduce a new paradigm to prevent face data from misuse. Our general idea is that, given a suspicious facial recognition models, we want to audit whether a target user's image were used to train this model. And if yes, we can take legal actions to correct or withdraw our data. This paradigm can be formulated as a user-level membership inference problem. To train the FACE-AUDITOR, we need an auxiliary face dataset, and this dataset can from different distribution of the training images of the target model. We first split the auxiliary dataset by users. For example, if the original auxiliary dataset contains 100 users, so each split will contain 50 users. We then split the first set by samples, such that each set also contains 50 users, but for each user, they only contains half of the samples. Then, we use the first set to train a shadow model that is similar to the target model. After that, we use the face images of the member users and the non-member users to construct a probing set, and then use this probing set to query the shadow model and generate a set of similarity scores. We should note that we do not need to use the member samples of the member users to query the shadow model. This kind of paradigm can make the deployment of FACE-AUDITOR easier. And after that, we can combine the similarity scores and the image level similarities and construct the auditing features. And we call the image level similarity, the reference information. Finally, we can use these auditing features to train the face auditor. Recall that we only need to use face images of the member users to query the shadow model. Therefore, when we use face auditor, we only need to prepare a set of face images of the target users, which are not necessarily used to train the model itself. So this can make the deployment of face auditor much easier, because we do not need to know the exact images used to train the model. We only need to collect another set of images of these target users to query the model. So to evaluate the effectiveness of face auditor, we conduct experiment on 4 face datasets, including UMD face, web face, VGG face, and Celibar. We also conduct experiment on 3 machine learning-based models, including CMS network, Proto network, and the relation network. We also evaluate on 4 metrics, including accuracy, AUC, F1 score, and false positive rate. In general, we show that face auditor achieves good auditing performance for all facial recognition models, the 4 face dataset, and the 4 metrics. We then show that the reference information that we incorporate in the auditing features can significantly improve the auditing performance. Comparing the similarity of the reference images, we find that we can achieve better auditing performance by using high similarity images. Through transferability experiments, we find that we can use different distribution face datasets from the target model to train the face auditor, and we can still achieve a good performance. We can also use a general facial recognition model different from the target model to train the face auditor, and we can see that we can also achieve pretty good performance. We also explore the robustness of face auditor when the model provider applies some perturbation in the construction phase of the facial recognition models. We first experiment on the input perturbation, where each image is pre-processed by image cloaking technique, such as the FOX. We show that the cloaked images does not severely impact the target model performance, and the face auditor is robust to the input perturbation. We then explore the training perturbation, where the model provider apply differential privacy in the training process. The experimental results show that the training perturbation has a severe impact on the target model performance, which is expected since the DP training will impact the model accuracy, where the face auditor is robust to the training perturbation. We finally experiment on output perturbation, where the model adds some noise to the similarity score output by the facial recognition system. The experimental results show that face auditor is also robust to the output perturbation. The accuracy job of our face auditor is very, can be negligible. So finally, I want to discuss a bit about the practical impact of face auditor. First, governments and the regulators can use face auditor as a tool for enforcing privacy regulations by determining if models are misusing data and violating individuals' privacy rights. Second, face auditor can be also used by individuals as an auditing tool to detect potential misuse of face data. If a misuse happens, they can take legal actions to correct or even withdraw their data. Third, face auditor can also be employed by model developers to conduct self-inspection and ensure that their models are compliant with privacy regulations while demonstrating transparency in their data processing practices. We open source our code and welcome to use our tool to do the face auditing. And thank you for listening. I'm glad to take any questions. Thank you.